teacher at Westside Middle School. I'm also the president of the Computer Science Teachers Association here in the Metro.
And so just to get some sense of the audience, how many here are work in high school, by show of hands? Middle school? Elementary school? University? Hands are too weak to go up. All right. The last talk that was in this room was about a bunch of tech stuff that, 3D printers and Arduinos and things like this. And given that context, I would like to kind of say a little bit of things about Bricklayer as it would relate to this kind of stuff. So, but what I'd like to do first is, if you go to bricklayer.org, that gets you to the website. And bricklayer.org has a YouTube channel, and it has a course, sort of a playlist in YouTube called Course 1 that you can click on. And there'll be more content coming. It's an evolving system. Just want to say a couple of very quick things. They were demonstrating how you could write programs for microcontrollers using block-based systems. So on Bricklayer, you can do this kind of stuff too. Of course, the things that we build are slightly different. So here's an example of programming on the web using the block-based editor. You can also, the majority of programming in Bricklayer, though, happens with the text editor. So let me show you this here really quickly. So I'm going to write a little Bricklayer program here and make it big so you can see, and I'm going to sort of tell you what I'm doing as I'm doing it. So Bricklayer is a graphics, the Bricklayer software is a graphics library, and it has different levels. So think karate, a black belt or green belt and stuff. And so this is level 4, which is the first level where you can do 3D, where you can build 3D artifacts. You build graphical artifacts, like Lego artifacts or Minecraft or things like this, made from blocks. So I'm going to create a build space, which is like a Lego base plate, except this one is in 3D. And the regular base plate in Lego is a 32 by 32. So this is the 3D version of this. And then there's a variety of functions that you can do in Bricklayer to create artifacts, to place bricks and stuff like this. And it's all well documented, and there's tools that help you understand how all this stuff works, and videos also. But this one here says put a 10 by 10 by 10 blue cube at the origin. And then if I show cube, and I save this off to my desktop somewhere, and then if I run this, it shows up in Lego Digital Designer. So Bricklayer ties in seamlessly to a bunch of third-party freely available software. So everything on the Bricklayer website is free. So this is our cube. And whoa, this is scary here. All right, hold on. It's a little loud. So I'm going to show you a fun capability that Lego Digital Designer has. Is everybody scared sufficiently? I can. So the blowing up stuff's really fun for all ages, including me. If you had the inside of this cube different colors, you could imagine it could, or if it was a sphere, you could do fireworks and things like this. So that's sort of a quick in the nutshell, but let me tell you what else it can do. So it can tie into Lego Digital Designer, it can tie into a variety of other tools, but given what happened, what was the topic of discussion in the last presentation, they were talking about 3D printers, and can you connect it to meaningfully to curriculum, right? So what Bricklayer does is it seamlessly integrates with 3D printers. So now this is I could send this to a 3D printer. So the question now is, if you're coding, if you're designing something and you want to print it at the end, you can do this, and it's really easy to do.
Okay, so I saw that the first time you had that program and you saved it to your desktop, it was a .bl Bricklayer file.
Right.
And this one is an STL file.
So the program text is Bricklayer. Yes. The output of the program text is a 3-dimension, an STL file or a Lego file or or a Minecraft file. So you literally can, if I have
All those options to export the.
all those options, yes.
Cool.
And it connects to the Arduino as well, though that's not documented yet. That's sort of in progress. So you can build cool things with Arduino LED displays and so on. So it connects to Arduinos soon, watch this space. It currently connects to 3D printing stuff. It connects to LDRAW. It connects to Minecraft. So literally, if I were to do, and in the interest of time, I'm not going to do this, but if I had a Minecraft server up and running and I did show MC, it actually shows up in a Minecraft world. So one thing that's really, really fun for kids, right? So you're coding, because it's discrete spaces, there's a lot of math that goes on, discrete math, right? You understand coordinates, you understand if I build something this big and I want to put something next to it, how wide is this, these kinds of things. So there's a lot of, a whole lot of math that underlies Bricklayer. And math, the understanding of math makes it easier to build things at the end of the day. Right, and so you have these things you can connect it to all these tools, and because of the art dimension, you can give open-ended assignments to kids. So you can say stuff like, the next one that we're going to do is castles, or architecture, or pixel art, or whatever, and it's really, really cool what kids of all ages do when you turn them loose like this, because they play to their strengths, and it is an amazing thing to see. So in class, what we've done before is you have a Bricklayer art show, everybody gets to see it and all this kind of stuff, but you're still in the room and the art is on the screen. But the latest, greatest version of this is a Minecraft art show. So the kids build something in Minecraft in a city, and then they get to go inside that city and walk through the other person's castle that they built. That is super, super engaging, really fun on all sides. All right, so that's my my little quick overview of Bricklayer. I felt, given the nature of the last talk, this was a good thing for me to start off with. And so the talk, right? Our topic is Bricklayer in the classroom, and what is Bricklayer, an overview and some stuff and technical challenges. And at the end of the day, using tech, as you all probably know, there's many challenges that are associated, and some of them are unexpected, actually, from my point of view. And then the question is, why do it? And so I want to talk a little bit about the motivation behind what Bricklayer is trying to do, sort of bigger picture stuff, and then bring it to the second part of the talk, which is about the technical issues and how one might work around this.
And what your classroom teachers might have to do to actually, work with tech support to get this in your...
All right, so I don't know if you've been keeping up globally or nationally, but there is this movement to mandate coding be taught from kindergarten on. So Australia has mandated it, England has mandated it, Finland has mandated it. Finland is a big one because they're sort of a shining example of a successful Western educational system, right? They're sort of one of the best that we have. So, and there's a number of other countries too. And in the United States, it's sort of a little bit more heterogeneous, right? So there's some cities that have mandated this, and then there's some states that have mandated it from middle school on, like I think South Carolina has done this, and Virginia is the first state that has mandated it across the entire K-12 spectrum. So this is a big deal because there will be other states. This is a domino. Now, when you want to teach coding, right, or computer science, this kind of stuff, ultimately it's about leveraging the power of the machine. And so what that means is you want to create a small program, the shorter the better, that produces a large number of computational steps that are somehow meaningful. And so that's what it means to leverage the machine. You don't want to have to write, if you want to produce 1 billion computational steps, it shouldn't be that your program needs to have 1 billion lines of code in it. That doesn't work. But in order for this to happen, there has to be a pattern in that computational sequence. And so it's the discovery of that pattern and expressing it concisely that's sort of the art of programming. And it turns out that this is across the scientific spectrum in math, right? So mathematicians, it's all about pattern now. Because the computer is your assistant, right? You don't have to spend as much time focusing on multiplying multi-digit numbers together and stuff like this. It's this higher level kind of engagement where the computer is just this awesome calculator.
And I found from a classroom, I mean, like students can already identify patterns. Like they might not know it, but they're already doing the computational thinking process. They just don't know that they're doing it. So like when I'm teaching computational thinking, I teach each of those steps, decomposition, pattern recognition, abstraction, and algorithmic thinking. Breaking those apart and having them relate it to something that is in their world, they're like, oh, I'm already doing this. And so that shows them how the computational thinking process, they can solve a non-technical problem. It makes it a lot easier to use that process when they're presented with a technical problem.
Mm-hmm. And so the question is, so you want to teach kids this kind of stuff, so what is the domain? Right, so at the university level, your first programming class, you read in a number maybe and it's treated as Fahrenheit and convert it to Celsius. That might be like one of your basic programs. So you deal with text, you deal with numbers and stuff, but I would say that humans are inherently good at recognizing patterns visually. So this is a really nice domain. I would say it's very suitable. And we have good company, people that we respect think highly of this kind of art, this visual domain, and there's this really strong connection between art and math. So this is a quote from Da Vinci, basically in a general introduction to painting, where he says, "Let no one who's not a mathematician read this book." The connection is that strong. So I want to give you a couple of links to sort of interesting research papers. So there's a bunch of these papers. So I'm just giving you just a couple to give you some sense of the landscape of what's going on out there. But so there is a lot of evidence to show that if you have good visual skills, you are good at math. And that, for example, if you take visual art class, it will make you better at certain kinds of mathematical thinking processes than if you didn't. And that art develops this, right? So you can develop spatial thinking abilities through the visual arts and through other kinds of block-based toys that boys tend to play with more than girls. Spatial ability is probably the number one predictor of your success in the STEM fields. This was a huge study that showed this. And also, it turns out that your mathematical thinking is grounded in visual stuff, in the visual part of your brain. So sort of highlighting from those kinds of papers, and there's a bunch out there, visual spatial ability is a powerful determinant of advanced mathematical achievement. Visual spatial working memory was the best predictor of mathematical performance in 6th grade. And it can be developed through the visual arts. And it's engaging. You can say Minecraft and 3D printing. So there's this, these neuroscientists are studying this too. And it turns out that when you do a numerical calculation, your mathematical thinking is grounded in visual processing, and those parts of the brain are engaged when you do this. So these are huge, hints as to, and if you look at Canada, so Canada has a really, really good school system as well, sort of on par with Finland. They do really well in these international tests and so on. And their education ministry or whatever, Department of Education, whatever, they're calling for the spatialization of the entire curriculum. They say it's that important. All right, and Einstein also considered himself to be a visual thinker. So we have Da Vinci, we have Einstein. This is and we have a lot of research to back this up, right? And so in that setting, right, so Bricklayer wants to engage with coding and math using the visual arts as the domain, as the medium. And so you can build all kinds of cool things. You can, and it can be two-dimensional, it can be three-dimensional. The Elvis one here was done by a 3rd grader. The John Lennon one was done at the university level by a student who wasn't an artist, but figured out a way to take a John Lennon picture and projected onto an image, onto a grid, and then coded up that grid like pixel art, and then did multiple copies of it and did this Andy Warhol thing. Let's see, what else? Pokemon Ball, kids like this. And this is a Minecraft, up on the right is a Minecraft building. This is from a real building in Islamabad. It's the crown jewel of Islamabad, this building. And so it is really, really cool to see how students abstract the building that they see. It's what details of the building you feel are important and which ones you want to omit. So for me, the omission I find is the most interesting, actually, to be honest. It's what they leave out. And so I don't know if you've ever seen VeggieTales, the movie, if you have kids, VeggieTales. I watched like the whole movie, and then I realized they don't have arms. But they were doing sword fights, and the sword is, and I just filled in the details. So when kids omit stuff, I find it just fascinating, actually. So the idea, right, is that you have this creative domain of art, and you're never too young or too old to do art. And if we did art, if I said pull out a piece of paper and everybody draw a face, there would probably be a smiley face somewhere here. I might do the smiley face, and then somebody else is probably going to do something really awesome. So the ability for art to challenge people of different abilities at the same time is sort of a really powerful kind of for free byproduct, right? This is nice. But anyway, so the idea, so you have art, you have math that just helps you learn how to build things more easily. It's the laziness, right? So you're doing math for a purpose, not just because you have to. And so math gives you shortcuts. I don't have to do this, or I don't have to like manually count how many cells I have to go over to position my next thing if I understand certain higher level things. So you get this math all the time. And then ultimately it's the computer that lets you realize this stuff. And when you're writing a program, especially in 3 dimensions, like 2 dimensions, it's pretty easy to sort of mouse click something out. We have some tools that let you play with stuff like this. But in 3 dimensions, you can't quite mouse click, and so you write a program to explore an idea that you have. And then your program kind of like, oh, that idea wasn't fruitful. Let me try a variation of this. But at some point, you say like, let me picture this a little bit before I write my program, just because I'm lazy. And if I can sort of picture a little bit and go like, that idea isn't going to be good. Let me try a slightly different one. You've saved time. And so automatically, it sort of just encourages you to think visually. You get rewarded for thinking visually. And so we have, and everybody that plays with Bricklayer will tell you that, yes, their visual, it seems to really develop their visual abilities. I mean, this is the adults, right? And we're in the process now of having data to back that up. And so we have this, last spring we did a pre and post test with some elementary schools, and we were able to show that there was a significant visual spatial reasoning ability that it increased significantly. And also coordinate graphing, which is also to be expected. But this visual one is we all knew this, but it's a really nice result. And there aren't that many, if you go out and Google surveys or studies that they do in schools about measured learning, they almost never show a change. The needle never moves. And so these studies end up being things like, do you like tech more after this? So they're sort of touchy-feely kinds of things, but this is hard data. Here's a slide from Kate Sherwin. She gave a talk with my wife, who's also in Bricklayer, at the NAG conference a week ago or whatever. And so she uses it in Nebraska City, in middle school, I think middle school and elementary school in their gifted program. And and she's done it for a couple of years now. And so here's sort of the math standards that she says for this audience that it addresses. So it addresses a bunch of math standards. We would like to, the next stage in our research is to demonstrate that actually if you did Bricklayer, instead of doing math 90 minutes a day for 5 days a week, if you took 2 45-minute periods out of that schedule and had that be Bricklayer, we actually think your math scores will go up. We don't have data to back that up, right? But this is what we would like. This is what we believe. And so we're looking into that, and hopefully we'll be able to report things like this at some future point. Setting up these pre and post tests takes an enormous amount of time, right? There's all kinds of permissions that have to happen and stuff.
Well, if you talk with anybody in just the computer science, I mean, computer science is foundational now. I mean, like, you need it to be successful in any career you go into. And so exposing students K through 12 to computer science, you're preparing them for, their future. So integrating it into math, integrating it into art, is just giving them more relevance to how they'll use those skills later on.
So currently Bricklayer is been used in about 80 schools in Nebraska, mostly around Omaha, but as far west as Grand Island. And but most of the use right now has been in gifted programs. And the reason why the gifted programs part is because that's where there's flexibility in the schedule, right? So we are making inroads on the getting it into the real curriculum. We're having some discussions with OPS about having Bricklayer actually in a school as a pilot for all the students. We are doing a Bricklayer. We're getting Bricklayer into the Wilson Focus School. So this is also, we're currently doing 2 back-to-back 8-week Bricklayer modules with them, with the teachers and with, I think, their gifted kids, and then in the fall it's going to go into the curriculum. So we are making progress, and eventually there will be a mandate. We can talk about how long this will happen, but eventually there will be a mandate from on high that says you must teach this, maybe not Bricklayer, but you must teach coding, computational thinking, this kind of stuff across the spectrum.
I was curious about Bricklayer Lite, what the difference is.
So Bricklayer Lite is a web-based editor, so it's a block-based coding environment, and it technically runs on the web, and it's behind the scenes is written in JavaScript. And JavaScript it's a subset of what Bricklayer actually is.
Right.
So
can you output those and download them to Arduinos and things like that?
So what you can do with Bricklayer Lite is it will, in addition, and I didn't show this, but I can if we have time and stuff. But so what Bricklayer Lite will do is it will not only produce the artifact that you created and let you save it as a Bricklayer Lite program to be loaded up on another machine, but also it will translate that program into an official Bricklayer program, a program text that you can then save and run like I just ran here and open up in Lego Digital Designer.
Right.
And the reason why that's kind of important is because Bricklayer itself is written in a functional programming language called SML. And SML is the class of functional programming languages have really, really nice algebraic properties as far as the ability to manipulate code. Think of factoring code, this kind of stuff. There are some languages that are exceptionally well suited to this kind of idea, this mathematical idea, and those are functional programming languages. And there's universal agreement among this, right? And there are other languages that are very ill-suited to this kind of thinking. So I'm a functional programming guy. If you go to SML is taught at Carnegie Mellon as their introductory freshman. That's their first language. If you go to the schools, I haven't done this recently, but I have done this several years ago. If you go to the schools that win the World Programming Contest and you find out what's the first language they teach their kids, very often it's a functional programming language. And the reason why that is, and I can go on and on because I passionately believe about this, this is what led to the creation of Bricklayer in the first place. So I teach functional programming, and I teach a programming languages class to seniors. And I thought that their understanding of code was blurry. They were very afraid to change code. They would sort of run code, and if it passed the test, they were done. They would never improve the code. And or restructure it, because restructuring it, separating out ideas or whatever, you risk breaking the program. And then it's a bunch of work. And so imagine if you're giving a speech. So you're a politician and you're giving a speech and you're typing it out on your text editor, Word or whatever, and the first time it passes the spell check or the grammar check, that's the speech you give. You will never be successful, really. So it's the art of, I have my first draft and then I'm polishing and I'm revising my ideas. That's where you learn your voice as a speaker, and that's where you learn your voice as a programmer. And that ability to do this was missing in the students that I
encountered. Light is web-based and regular Bricklayer is computer-based.
Computer-based, right. And so Bricklayer is a general purpose programming language, or SML in which Bricklayer is written. What Bricklayer really is it's a graphics library that goes with SML.
Is it not as full featured?
Bricklayer Lite is not as full featured.
Right.
Yes.
Not as full featured, only it's web-based. So.
Right. Web-based, so easier, more easily accessible. You don't have to install software. Not so much maintenance, but it is somewhat limited, but not for the beginning stages, right? And so the important part about the SML in Bricklayer is that because SML is a general purpose programming language, any idea that you think of can be expressed. And a lot of other languages are not of that kind, like Scratch or Code.org and stuff like this. You can do cool things, but there's a limitation as to the idea, as to what you can express. If you said in Scratch, I want to define functions that do polar coordinates and sine and cosine, you really can't, unless they've provided that already for you, right? So it's limiting in that sense, though it is immensely popular, right? So the idea was, I did Bricklayer originally because I wanted to clear up the thinking of the students that I was seeing at the university level, and I wanted to catch them as a freshman. Their first programming class is going to be Bricklayer, and so this is how it started, and then from there it kind of went to, maybe if you want to catch them in their first programming language, maybe you need to go to high school, right? And then the game, and so now we're sort of across the whole spectrum at this point. So one thing led to another, and this is where Bricklayer came from. So hopefully I've convinced you at least to consider the idea of putting Bricklayer to the classroom. We do free teacher training, all this kind of stuff. We do anything we can to support you. So anybody that's interested, please, reach out to us and stuff. But now suppose, there are a number of teachers that have done this, and that gets us to this next part of the presentation here, right? Which is this tech side of the story. I don't know if you know where that picture is. Anybody?
It's from West Side Story.
West Side Story, yeah. So this is the tech side of the story.
Good job. So I actually approached Victor to come and teach Bricklayer in my after-school computer programming club. So that's where I wanted to.
Yeah, and so it turns out, with a lot of times, even in the gifted programs and stuff, they have these modules, right? So does anybody here teach gifted? Anybody? Okay, so this is actually good that we're reaching but so they teach these modules during the year, some number of modules. So there'll be a science module or whatever, and it lasts some amount of time. I'm not exactly sure how it's structured, and I think different school districts have different rules on how all of that works. But they'll have 10 weeks, for example. And then 10 weeks, what will happen is week 1, nobody will be able to access the stuff. And then week 2, the teachers can see it, and they think everything works, and then the students can't see it, or they can't see half the stuff that the teachers want to see, right? And then week 3, the students can see it, but the way they're interacting with Bricklayer, it creates a Wi-Fi demand on their system that the system can't handle. And then and it just keeps going, right? And they go okay, so we actually have this offline version of the website on a thumb drive. Well, who has the thumb drives now, right? But we can't download software from the thumb drive onto the machine. I mean, it's just one thing after the other, right? And then in the mix, depending on when you do this, and then by the way, there's NISA testing or whatever, and then you can't have the computers for the 4th week. Forever. It's like this, right? And so there are some system requirements for Bricklayer, depending on how you want to use it. Chromebooks are too thin for the full Bricklayer experience, right?
So you could do light.
You could do light, right? So you could do the web-based stuff.
So what we did is we kind of went through and started to think about what are the steps that the teachers would need to do. How would they communicate with their tech support to get this going in their classroom? And so that was kind of my part of what did I need to do as the classroom teacher to get these students, if these websites operating on their computers within our school network. And so these were actually all of the websites that I had to send to my tech support guy. And it was kind of interesting because I sent him one, the bricklayer.org, and I didn't realize that once you go to bricklayer.org, it actually reroutes you to another website. And so I'm not going to pinpoint my tech support guy, he's in here right now, but I actually called him when he was sick and asked him if he would open up these other 2 websites so my kids could do this after school. So that just goes to show that tech support is working all the time. But that was just a problem that I didn't think that I was going to encounter, but I did. And so knowing this, we thought this would help you with your teachers if they're wanting to integrate this, the steps that they would have to go through to get this up and running. I mean, obviously the Bricklayer Lite, but with the limitations, why not have the full program?
It's not a big program, so it's not too hard.
Yeah.
Yeah, so the problem a lot of times, right? So in Christine's case, this was a wonderful tech support guy. I'm trying to see who's. But a lot of times it's like.
Was blocking this?
Yeah. So it was and partly it was blocking the WordPress, which was the reroute from the bricklayer.org. And so they could get there, but then they couldn't go to the different pages within the website. And then obviously the YouTube channel to be able to watch those informational videos.
And do you have your students watch the YouTube? Because there's a whole bunch of them on Bricklayer.
Mm-hmm.
Yeah.
Do you have them watch those? And
so Victor was actually in the room, but I had the kids do that outside of club time because I just meet with my club kids once a week. And so from week to week, Victor would be showing them something, and then for the next week, they would watch videos to prepare for his next lesson.
And they would do that at home?
Yes.
Because they can't get to YouTube from school?
No, YouTube
Some.
is within our network, kids can. But the channel, I think, was also, like, if they went to if I sent them specific links to videos, they could do that, but the channel they were having trouble with.
Yeah, so there's all these unexpected things, and ultimately, it just takes it takes time to get all of this ironed out. And if the clock is ticking as far as what you're teaching goes, this initial getting it all up and running can be unexpectedly difficult. Now, the goal with Bricklayer, the website, is it's supposed to be you should be able to teach yourself. There's supposed to be enough engaging stuff that if you want to learn, there's enough stuff here so that you can learn, and enough self-feedback. And I can show you a couple of things of like self-grading assignments and stuff like this. And so that gets back to a little bit of the role of the teacher in the classroom, right? So a lot of teachers are intimidated by tech. And there are some hotshot kids, and this is the really amazing thing. One of the things that I really, really like about teaching below the university level is that you see the kids get better in front of your eyes, right? This does not happen at the university, or extremely rarely. They come into your class good and they leave good. They come in bad and they leave bad, and it's very rare that you have sort of seen this come in good, come in bad, leave good, right? But with elementary school, next week so these kids pick up this stuff incredibly quickly. And you do have some hotshot kids that are living, their parents are techie and all this kind of stuff, and they like to show off, right? So this is can be sort of an intimidating environment. But if you think about it in terms of art, so I think this is the role of the teacher, right? If a kid can draw better than you, this is not intimidating to the teacher at all, right? And so, or if you're coaching football and the kid can run faster than you, it's not intimidating, right? It's this higher level. It's inspiration, it's direction, it's motivation, it's all of this sort of the magic that the teachers bring to the classroom and keeping them on task, right? That's another thing too. But also finding what resonates with the classroom. So I teach my kids, my wife and I, we teach our kids code almost every day, and it's rare that we actually get down and get all nitpicky with them. So like, what are you going to build? Oh, we're going to build it. How about if, could you do this? And it's sort of brainstorming. It's sort of the idea part. It's forming the idea. And then the rest of the stuff is just sort of like the paintbrush meets the paper part, right? And so what we also are setting up is an online help desk to help this problem. So our online help desk is kind of sputtering because when we have money, we fund it and we have people manning it, and then when we don't, it kind of becomes defunct. But in a perfect world, this online help desk would be around 24/7, and you just sort of drag a program in there. Why doesn't this program run? And you get the answer back. Now, that is probably most useful for programs that don't compile. That's like the biggest win for in elementary school and stuff. It's really frustrating if your program doesn't compile because it's hard to like, what do I do next? However, once it compiles, if this blue brick is too far to the right, that's sort of something that kids can play with, right? This is a sort of I can kind of tinker with this and tweak this a little bit and move things around, and as a result of this, my mathematical understanding gets better, by the way, too, so I don't make this mistake so often next time. But so there's a way to support, right? So we have in our game plan a way to support tech in the classroom. So we really would like to take the concern that teachers may have with tech away out of this and have enough videos and YouTube videos where kids can learn all kinds of stuff that they want to at whatever level they want. So this is our big vision for this.
A teacher that's passionate about wanting to integrate computer science and just and technology. When we got into this experience, we didn't really plan what we were going to do with the kids. The first time, we actually figured out that a few of the kids had already known Victor, and so they'd already kind of gone through some of the intro Bricklayer. So we just were like, all right, well then let's start here. It personalized the experience for them because we were doing what they wanted to do. Like you were just like, okay, let's build a castle.
That's it.
What do you guys want to build? Everybody loves Legos.
And we're going to put it in Minecraft and have, at the end everybody gets to run in there, which of course opens up the door to, is Minecraft permitted? The one thing about YouTube is that Westside, their policy permits YouTube, but like OPS I think doesn't.
Yeah.
So it's not even a uniform kind of, one school, all of this might be just fine. And we have ways we can move these videos into screencast. There's these other tools that are approved, these video streaming things that are approved by schools in general or whatever. But those are there are a lot of issues. We have, so here's an example. So we have these videos, and we have a course which is just a YouTube playlist that just says do this, do this, and then the next video says do this next thing, and here's how you do the next thing. And so I didn't play all the videos to see if they would go through, but it looks like the first one is running, so it's running, but then all the other ones say this video may be inappropriate. So I don't know if it's blocked or if I just get to the end of this first video, if the other one just suddenly becomes appropriate and we can keep watching it, but it's a concern. I didn't have time to track this down.
If you have Google domains at your school, you can go in and approve individual videos for your domain. So
okay.
If it's logged in through you, we have it at Brown Owl, so if a kid's logged in to Google with a Brown Owl email address, I can go in and approve any video for them.
Okay. So if we had a list...
So if flags is inappropriate, you just need some administrator to unflag it, to approve it.
So a good idea would be, if I'm understanding what you're saying, is if I had a list of the YouTube links to videos, like 20 videos.
He can manage them.
Yes. Okay.
I can manage them and
Okay.
So again,
awesome.
another thing a
and
teacher
really
would
what
need
it
to
does
have.
is like when I log into that as an administrator, underneath the video, it says, "Do you want to approve this for brownout.edu?" And then we just click it.
Okay. Awesome.
So Wade, what you're saying is that YouTube's blocked except for the ones that are approved.
For whatever reason, it flags as inappropriate, which you never know why they.
Yeah.
Why
But you have YouTube open to your students.
Yes.
Yeah, we do too, and it's just, we just have safe mode enabled.
Yep, same, yeah.
Yeah, and then there's just a little banner that comes up across the bottom that says, do you want to approve this for your organization? Because it, it's easy on our end.
Cool. Good to know. So I think one of the things
That would be something that the teacher would have, I mean, like, classroom teacher, we wouldn't know that, so we have to communicate prior to these lessons.
Or you could appeal to your technology
Yeah,
department and see if they allow teachers to have that. It's just, I mean, it's a setting in the admin console, it's not hard.
yeah.
Right? You just gotta be able to trust your teachers.
So what I think we would like to do, because there's new information now that I didn't know, and I thought I knew all of this more or less, but I think it would be a good idea from Bricklayer's side to actually have a document or a packet or whatever you want to call this.
Yeah.
That you download this, and if you want to get the tech side of stuff, if you want to use Bricklayer in the classroom, download this document and it'll tell you, send this to your sysadmin guys, and these are the things that have to get unblocked, and this
That
is.
might be one of those fears of the teacher, like, of integrating.
Yeah.
They don't want to be that classroom teacher that doesn't know how to fix something, if something, if a challenge arises in the classroom. And so it's different having like you in the classroom, but if you have a close relationship with your tech support, then you can call them and.
Well, and it's also, if you are, I mean, it is kind of an inefficient use of time, right? If you're teaching, if you decided, okay, we're going to do this, and guess what? The first 3 weeks is I'm down, right? So at some point I'm wasting the student's time. So it'd be nice to know on day one, I have checked all the boxes that I need to check. So, so this is good. Thank you for sharing that. So here's another one, right? So you get, and I tried, so one of the things that I tried doing is I tried opening up a mobile hotspot, right? But my mobile hotspot was going through the school's Wi-Fi. It was blocked. So you have to go the other way if you're going to do stuff like this. So there's a lot of these issues, but so on the web-based stuff, right? So suppose you get all of these URLs unblocked and now you can go to all these places, then you get the next set of problems, right? And that is you have a classroom of a certain size, and there's some tools that we use online that are web-based stuff, and so they have to talk to the internet and to Bricklayer, and they use bandwidth, and then if you get too many kids in the room at once doing this, then all of a sudden things grind to a halt. And so they have had, there were these questions that said, okay, must be a bug with Bricklayer, and then they've brought in their tech guys to analyze stuff, and they go like, nope, it's not a Bricklayer thing, it's a Wi-Fi thing. And so we have sort of, because it starts things start not behaving the way you'd like to see them behave, right? And so on our side, right, when we see experiences like this, and sometimes it's a graphics limitation too, there's weaker graphics cards that can't process things as much, like Chromebooks tend to be in this category. So we have sort of this, the plain and the Lego version. So here's a grid. So this is a tool that we provide that you can sort of resize, make different sizes, and you can kind of draw out patterns. You can do this unplugged stuff. So you can learn a lot about creating algorithms, about seeing patterns this way. So a really cool assignment is you open up a grid of a certain size, and you can in real time make it bigger. So if your pattern hits the edge, you can make the grid bigger and you can move things around. But you have to create a pattern where something needs to repeat, and in 5 minutes you're going to switch with your neighbor, and they need to keep working on your pattern. Because the idea is that people sometimes think they have a pattern in their head, but if nobody else understands what that pattern is, then it's not really a pattern, right? So it's not this free-form art, it's pattern. You can do tessellations this way. There are certain kinds of algorithms. In tessellations, think of tiles, like kitchen tiles that repeat somehow, right? And the size of the tile stays the same, is constant. There are other patterns where the thing that repeats changes its size. And those things are fractals. So we have these algorithms and tools that show you how to create these kinds of things. But if you do this all with mouse clicks, then you get a very informal, nonverbal understanding of algorithm. out of this, right? So you can spend a lot of time exploring lots of interesting algorithmic ideas about alternating color sequences when you do tessellations and stuff like this, that develops this informal understanding. If you have better graphics and better Wi-Fi, you can see sort of the Lego guys. We have the same thing with Bricklayer Lite. So here's a little program that does the flag of Denmark. And if you have more Wi-Fi, more graphic stuff, you can sort of see this. You can make these selections. That's our reaction to, or one of our reactions to these kinds of problems. The Wi-Fi problem, you can, if you have a phone that has it, of course it depends on your data plan and stuff like that too. But you can get past some of these things, at least in an emergency situation. It's kind of, for me, I kind of panic a little bit if I get into the classroom and then nothing works. It's like, okay, so I don't know what to do now. So you can work around this, and we've had to do this more than once. And so we taught at this Omaha Homeschool Learning Center, and they didn't have Wi-Fi and stuff. And so we did hotspot, but we also did this Bricklayer. As a result of this and these kinds of situations, we developed an offline version, right? So you can go to the website, and it's not the fully featured one that you see here, but it has all the tools. It has Bricklayer Lite. It doesn't have the text-based thing because that requires a software install. But you can actually download that and put it onto your thumb drive, and then either run it from the thumb drive or copy it onto the machine.
Yeah.
And so the problem is, if you plan on copying it onto the machine, then the students have to have the ability to copy this stuff onto the machine. So we discovered this at Wilson Focus School, that there was this bandwidth issue. So we said, okay, here, do this. And like, okay, well, now next step is we can't copy it onto
the flash.
And well, then so if you run it off the thumb drive, then you need a thumb drive for every machine, right? So so it's not, solving one problem sometimes creates a different kind of a problem. And then we have the software installs, and there are a number of ones. So Bricklayer connects with a bunch of stuff. You can install Minecraft, a Minecraft server, which is on the website and freely available. But the vanilla Bricklayer, right? The generic one is you install this text editor, this IDE, and then Lego Digital Designer. And if your computer can't handle the graphics requirements of Lego Digital Designer and it's stated what it is, then you can do LDRAW. So LDRAW is a more lightweight as far as what it needs from graphics.
So with these, I had to work with my tech support to put these two pieces of software on our software management system, and then students just went there and downloaded it. If your district doesn't have a software management system, then that would be the tech support having to touch every single computer to install it. But the kids love. It's just amazing to see the way the kids
What grades do you
interact
work
with this.
with?
Say it again.
What grades do you work with?
7th and 8th grade.
Does the Bricklayer Lite run on like an iPad or?
Yes, you can run it on your phone too. If the screen gets smaller at some point, it doesn't look so nice. And I'll show you. I will show you a couple of things. I think we have a couple of minutes at the end. We wanted to say it,
Yeah.
and so I'll show you some Bricklayer Lite stuff. It does all of this stuff. Sort of runs on a phone. At the end of the day, we've had students do this where this is their only device, but it's a little bit. It's not optimal. But iPad works pretty well, I think.
Okay, thank you.
You're welcome.
As far as paperwork, this is just something that with my tech support at my school we've devised. You can go to the next slide here.
Okay.
This is just a form that I have students sign themselves as well as take home, because we don't want to be just installing software on kids' computers and their parents not knowing what they're what they're doing. But also with this software being installed on student computers, our tech support had to change up the permissions to be able to have that software run properly. And so this form is just the student's notification that if you are going to use this, you are still you still have to abide by the code of conduct, the loan agreement that you signed. And so this is just documentation that can be used by tech support. And I use this for all different softwares. I have a couple kids in my computer programming club that are doing some stuff in Unity, the Unity game engine. This is the first thing I had them, and I not only did I just give them the form, we had a conversation about what are you using this software for, and that not every student in our school is getting this opportunity. So it's not just saying give the paper and have your parents sign it. You need to have a conversation with the kids about what they're getting into. So I have hard copies of this too, but if you want an electronic copy, it's just a pretty standard form. I didn't come up with the verbiage, my tech support guy did. So.
All right. So I would like to we have a couple of minutes left. I wanted to show you a couple of things. So the place where you get started with Bricklayer,
2 minutes maybe.
okay, is in this app called Vitruvia, and there's a lot of documentation and stuff, but let me skip to the nuts and bolts of this. And it starts out very, very simply and has these bunch of concepts that get more and more complicated as you get further and further along. But the beginning starts out assuming almost no knowledge at all, right? So it says, we want to put a 1x1 green brick at these following locations. So I'm teaching you about coordinates, right? So you can put this stuff, I made a mistake here. When you think you have it right, you can, and I'll tell you this, I can, if I don't remember how coordinates work, I can turn them on and off. So, and there's a bunch of exercises in concept 1.
And
right?
this is where we found out that a lot of the kids, they're like, this is too easy. And so you can actually take a test for each concept, and you can bypass into the next concept. So we had a lot of kids just going straight into concept 3 and 4 because they had already grasped the concept of coordinates.
Yeah, so you can create these tests if students feel they know this, and we're going to try to gamify this too and have leaderboards and stuff. But the test tells you how much time you spent on each exercise, whether you got it right or wrong, all this kind of stuff. But the idea is that from Vitruvia, so just to kind of show you where this ends up, if I go to concept 23, we're talking about Boolean algebra, traversal of quantified formulas over 2 and 3 dimensional spaces, right? So it does get very high, but it does this gradually. So the first concept just tells you about coordinates. We skip concept 2, that's for kids that want to think outside the box a little bit. Concept 3 just tells you sentences of putting bricks at certain locations. What does it mean if a brick is bigger than a cell? In English, we get practice with this, and then eventually we translate that English understanding into code. So the English understanding part is somebody should be able to write on a piece of paper a sequence of instructions and give a kid a base plate and a bucket of Lego bricks and say, build what it says in this document. And once you're comfortable with that, one human communicating to another, then we just need to have the human communicate to the machine. And so that's how the coding part starts. So it's very gradual and very much supported by a lot of tools. The grid you can play around with to try out ideas, and then we have Bricklayer Lite, which is very lightweight and runs very quickly and gives you certain error messages if you're doing, it helps you if you got things wrong, if you built things incorrectly.
Any questions?
Any questions?
Thank you.
Thank you very much.